Hello and welcome to the ISIS tutorial. My name is Felix and this is the second episode. In this episode we will talk exclusively about arrays. Now you might think, why is he spending a whole episode on arrays? Well, the thing is, arrays are really powerful and important, so I think it's worth talking for 15 minutes about them. If you have used IDL before, you know what I mean. In the last tutorial, we learned how to declare simple variables just by typing x equals 5 and how to print them out if we just type x semicolon. But what happens if we want to group some variables together into one unit? Well, that's where arrays come in. Arrays are just an ordered combination of things, of numbers. If this reminds you of the definition of a vector, well, that's right. Arrays have many things in common with vectors. To define an array, we just write the variable a equals, and then in square brackets, the ordered list of things we want to have in the array. Let's say 3, 4, and 5. Then close the square brackets, and at the end, don't forget the semicolon. And so you see, the entries in an array are separated by commas. Okay, let's see what we've created. A semicolon. Oh, okay. Here, ISIS does not print out all the values of the variable or of the array, but just tells us some information about the array. That is, its type, integer type, and its length, 3. And that actually makes sense, right? Because imagine you have an array with like 10,000 elements. You don't want that spamming up your whole screen just like that. So we only get the most important information about our array. That is its type and its length. If we define another array, let's say f equals square brackets 3.2, 4.5, 2.3, 4.5, semicolon, and we look what that is, f, then we see it's a double type of the length of 4. Arrays can also have the length of 1. For example, e, and then square brackets 5.3, e is a double type of the length of 1. And you can see, even though it's only one entry in the array, we still only get the overview information about it. Arrays can actually have also the length of 0, but we will discuss this in another tutorial. In an array, you can mix integers and doubles, but the resulting array will always be double. That is, the integer will be typecast to double. So let's say g equals 3 and 4, two integers, and then 5.2 a double. Then we look at G, and you see G is now a double type array. Okay, so maybe you want to print out the contents of the array after all. Well, for that, there's the print function. So we just write print, and then in parentheses, the name of the array we want to print out, let's say G. And then ISIS prints out all the values of the array in the right order on the screen. And as you can see, the integer numbers we defined, 3 and 4, have now been typecast to double. Of course, you can also define an array by using other variables, like the variable x we defined at the beginning. So h would be 3, 4, and x. And then we look at h, and you see it has the value 5 in there, which was what we defined x to in the beginning. You can not only combine numbers into arrays, but also strings. Let's define array st equals, and then the string a, the string b, and the string 5. And then close the array semicolon, and look at st, and that's now a string type array of the length 3. If we print st, ISIS again shows us the contents of the array, and you can see that each little value in there has a quotation marks around it. So it's clear it's a string and not something else, which is especially important for the number 5, which also could be an integer. But if you want to combine strings and numbers into an array, that does not work. So st2, let's say, would be a and the number 2, ISIS will throw us an error. And that's because ISIS does not know how to typecast a string to a double. This is very similar to how you cannot combine strings and numbers in an operation. What can we do with arrays? Well, that's very similar to what we can do with variables. So we can do multiplication, division, summation, and subtractions. let's define two more arrays like that, A1, and that's 2, 3, 4. And in the same line, let's define A2, and that's 34, 35, and 5, semicolon at the end. And then let's sum them together. Our sum equals A1 plus A2. Let's have a look. Print our sum. And you can see ISIS does an item-wise summations of the entries of the array. So 2 plus 34, 3 plus 35, and 4 plus 5. And also the multiplication and the division are item-wise. So if we look at our mult, which we define as the multiplication of A1 and A2, and we have to make a semicolon, not a double dot, our mult is now still an integer type array of the length of 3, and if we print it, we'll see it's the item-wise multiplication. And this is very similar to what you would call a scalar product or a dot product for vectors. If we just sum over our mult, we get exactly the dot product. So let's print out the sum of the array our mult, and you see it's a scalar, and that's exactly what the dot product would be. Of course, for these operations to work, the arrays have to have the same dimension. So for example, the array 2, 3 times the array 1, 2, 3 will not work. If you don't want to get or use the whole array, but only specific elements of it, you can index an array. To do that, we use square brackets directly after the array name. So A1 of 0 gives us the first entry of the array A1. And you can see ISIS starts counting at 0. So the first index of the array is indexed with 0. A1 of 1 would give us what we usually call the second entry, and A1 of 2 gives us, in this case, the last entry. If we use a number that's larger, like A1 of 3, we will get an error called invalid index, because we try to get an element outside of the array. If we don't know the length of our array, which can happen, but we still need to get the last element, we can count from the back. This time actually starting at 1 using a minus sign. So A1 of minus 1 will give you the last element. A1 of minus 2 will give you the second to last element. And then A1 of minus 3 will give you, in this case, the first element, because our array was a length of 3. We can even use arrays as index arrays. So we could say print and then A1, and don't print the whole array, but only something we index. And let's use an array to index. So we open another array, and let's say 0, 1, close that array, close the other set of parentheses, of brackets, close the parentheses, and then hit return. And you see it prints out the first and the second value of the array. Be aware of the double brackets, right? The outer one indicates that we want to index the array. The inner one creates the index array itself. We could also do that in 2 steps. Creating another array first, let's call it index equals 0 and 1. So this array is now filled with the number 0 and 1. And then use this to index our array A1 by just typing it within the one set of square brackets. And that's exactly the same. Arrays don't have to be one-dimensional, but can have multiple dimensions. To define a multidimensional array, we need to specify the dimensions of the array before we can put numbers in. So we have to declare the array before we can use it. To do that, we say b equals, and then we have to specify the type of the array. In this case, let's use double type, so double underscore type, and then in square brackets the dimensions we want to have, let's say a length of 3 in one dimension and the length of 4 in the other dimension. And then we look at b, and now it tells us that b is a 2-dimensional array. If you print out that array, you see it's filled with zeros, and ISIS prints it out in style of a matrix. We could also have created an integer array by doing c equals integer type of 4, 5, and 2. So this would be a 3-dimensional array. And so you see you're not limited to 2 dimensions. To assign values to the array now, so to fill the array, we have to index the specific entry we want to assign a value to. For example, let's assign the first entry of B, and there we do 0, 0. So the first entry in one dimension and also the first entry in the other dimension equals 5. And then we print out B, and you see now in the upper left corner we have a 5. And you see the 5, even though it was an integer, got typecast to double type because we specified that the array should be double. To be clear, right, we here only use one set of brackets, but we need 2 indices to address the 2D array correctly. So you always need as many indices as you have dimensions in the array. Of course, we can also combine this with indexing arrays. So we can say B, and then let's use an array of 0 and 2 as the first dimension, and then for the second dimension let's use 2 and 3, and then we close the brackets and then assign a value, let's say 8. And then we print out B, and now you can see we have 4 8s in here. We have 2 8s here, that's the 0th row and column number 2 and 3, and we have 8s here, that's row number 2 and column number 2 and 3. So because we start counting at 0, that's how it works out, right? We could also use only one entry in one dimension. So for example, B of, let's say, 0 and 2 again, but this time only one number in the other dimension should be 7. And then we print out B again, and print out B again. And then you see we have 7s now here and down here, which is in the column number 1, in row number 0 and row number 2. Maybe this might look a little confusing, but it's very powerful, as you will see later. And last point to indices. All indices have to be integer because, I mean, floating point numbers can't really work. This is not only true when you try to say like a1 of 1.5, because, I mean, ISIS would not know what to do with that, but also if you would try a1 of 1.0. Even though 1 would be actually a nice index, it still is a double type, so it does not work. And that's why typecasting to integer can be important. So as we learned in the last tutorial, you can typecast something using the int function, and then we can typecast our double value to integer, and then we get out the right number. So please make sure that all your indexes are always integer. There's another way to create an array, and that is to create an array running from number n to m, which we call a range array. And to do that, we would define c equals, and again square brackets, and let's say it should go from 1, and then double dots to indicate the range array to 31. And that creates an array with exactly 31 entries. And when you look at them with print c, you see that it starts at the first entry we specified 1 and runs all the way to 31 in steps of 1. You can actually specify the step size, so you could say c equals going from 1 to 31, and then another set of double dots, and let's say in steps of 2. And that would give you just only the odd numbers in that array. We can even create arrays with a non-integer step size. So let's say D is now again going from 1 to 31 with a step size of 2.5. And then print out D. And you see now basically every 2.5 entry is in there. And the array is implicitly typecast to double because we used non-integer when we declared it. And if you look at it closely, you will notice the last entry is missing. 31 is missing. I mean, 28.5 plus 2.5 would be 31, so you would expect it should be in there, but it's not. And that's the main difference between double type and integer type range arrays. Double type arrays will only go very close to the upper limit but never reach it, while integer arrays will always include the last number, as we can see in C, which goes all the way to 31. This actually also holds if you use a step size of 1. So if you compare print and then the array 0 to 4.0, so a double array, it only shows you the entries 0, 1, 2, 3, while if we use print and then I just make it integer by deleting the 0 here, it goes all the way to 4. In the case you don't want to create an array with a certain step size, but with a certain number of steps, you can use the hash. So g equals, let's say, 1 to 31, and then hash 15 steps. And then we print g, and this you can, and let's have a look at g like this, and you can see g is an array with exactly 15 entries, and they are spaced equidistantly between the limit we specified at starting point and the one we specified as endpoint 1 and 31. And in this case, both endpoints will be in the array, even though it's always a double array. Okay, that's about all for arrays for now. We have seen that we can combine different things together in an array using square brackets and index them using integer values. In the next tutorial, we will talk about structures and lists. Thanks for listening.